Good day, students. Welcome to this JSS 1 Basic Science lesson on simple machines, their types and uses. A machine is a device that helps us do work more easily. Simple machines are the building blocks of all complex machinery. The wheel on a bicycle, the blade of a knife, the inclined plane of a ramp, these are simple machines that appear everywhere in Nigerian daily life: the palm oil press, the hand pump well, the screw jack, the crowbar. By the end of this lesson, you will be able to define a machine and explain the concept of work, identify the 6 types of simple machines, explain how each simple machine reduces effort or changes direction of force, calculate mechanical advantage, and give Nigerian examples of simple machines in daily use. Let us begin. Key definitions. Work. Work is done when a force moves an object in the direction of the force. Work, W, equals force, F, times distance, D. Unit, Joule, J. 1J equals 1N times 1M. If a force of 10N moves a book 2M, work is equal to 10 times 2 equals 20J. Note, if you push a wall with all your strength and it doesn't move, no work is done, no distance moved. Machine, a device that uses a force, the effort applied at one point to overcome a resistance force, the load, at another point. Machines do not create energy, they redirect or transform it. They make work easier by reducing the effort needed, changing the direction of effort, or increasing speed. Mechanical advantage, MA, the ratio of load to effort. MA equals load/effort. If MA 1, the machine multiplies force, easier to move a heavy load with less effort. If MA 1, the machine multiplies speed/distance at the cost of greater effort. Velocity ratio, VR equals distance moved by effort/distance moved by load. Efficiency, percent equals MA/VR times 100. A perfect machine, 100% efficient. Real machines are always less than 100% due to friction. The 6 simple machines: lever, wheel and axle, pulley, inclined plane, wedge, screw. 1. Lever. A rigid bar that turns on a pivot, fulcrum. 3 components: effort, load, fulcrum. 3 classes. Class 1, fulcrum between effort and load. Effort, fulcrum, load. Examples: crowbar, prying up a rock, seesaw, playground, scissors, compound, pliers. Nigerian use: crowbar for prying roofing sheets, bottle opener. Class 2, load between fulcrum and effort. Fulcrum, load, effort. Examples: wheelbarrow, bottle opener, alternative model, nutcracker. Nigerian use: wheelbarrow on construction sites. Class 3, effort between fulcrum and load. Fulcrum, effort, load. Multiplies distance/speed. Examples: tweezers, broom, fishing rod, human forearm. Nigerian use: broom, a common tool in every Nigerian home. 2. Wheel and axle. A large wheel attached to a smaller cylinder, an axle, effort applied to wheel, load moved by axle or vice versa. A rotating type of lever. Examples: steering wheel, car, doorknob, windlass, rope winding well, pencil sharpener, bicycle gear. Nigerian use: steering wheel of Okada, motorbike, handles, less obvious, but most relevant is the hand-operated well windlass for drawing water. 3. Pulley. A wheel with a groove and rope, changes direction of force and or multiplies force. Fixed pulley, only changes direction, not force. More equals 1. Example: flagpole rope, well rope over a pulley. Movable pulley, reduces effort to half. More equals 2. Block and tackle, compound pulley, several pulleys together, MA equals number of rope sections supporting the load. Used to lift very heavy loads, engines, shipping containers. Nigerian use: dock cranes at Opopo/Lagos Port, mechanics engine hoist. 4. Inclined plane, ramp. A flat, sloping surface, allows heavy objects to be lifted gradually with less effort over a longer distance. MA equals length of slope / height. A gentler slope equals more MA equals less effort needed. Examples: ramp for wheelchair access, road cutting through a hill, loading ramp for lorries. Nigerian use: ramps for loading heavy goods into trucks, hillside roads. The Oroba Hills Road in Ondo State uses inclined planes. 5. Wedge. Two inclined planes joined at a thick edge, converts downward force into a sideways / splitting force. Examples: knife, axe, chisel, nail, needle, razor blade, doorstopper. Nigerian use: machete / cutlass, an essential Nigerian farming tool. The blade is a wedge, axe for firewood splitting. 6. Screw. An inclined plane wrapped around a cylinder, forming a spiral helix. The thread of a screw is the inclined plane. Examples: screw, fastener, nut and bolt, car jack, screw jack, corkscrew, drill bit. Nigerian use: screw jack for lifting vehicles. Mechanics, borehole drill rigs use screw mechanisms. 3 examination questions. Question 1. Identify the class of lever in each. A. Scissors class 1, fulcrum between effort and load, 2 class 1 levers joined. B. Wheelbarrow class 2, load between fulcrum and effort, wheel is fulcrum. C. Fishing rod class 3, effort between fulcrum and load, your hand is effort, the butt is fulcrum. Question 2. A mechanic uses a lever to lift a car engine weighing 800 N. He applies an effort of 200 N. Calculate the mechanical advantage. MA equals load / effort equals 800 / 200 is equal to 4. This means the lever multiplies the mechanic's force by 4. He lifts 800 N using only 200 N of effort. Question 3. Give 2 reasons why simple machines are important in Nigerian daily life. A. Reduce the effort needed for heavy or difficult tasks. A farmer uses a cutlass, wedge, to cut crops with less force. A builder uses a wheelbarrow, a class 2 lever, to move heavy sand. B. Allow work to be done faster and with greater precision. Pulleys in cranes allow dockworkers to move heavy shipping containers that would be impossible to lift manually. 3 common mistakes. Mistake 1. Thinking machines create energy or reduce the total work done. Machines never create energy. The total work done, load times load distance, always equals the effort times effort distance, in a perfect machine. In reality, some energy is lost to friction, so total energy input is always slightly more than work output. The machine makes it easier by distributing force or direction, not by reducing total energy. Mistake 2. Identifying all knife-like objects as levers. A knife is a wedge, not a lever. Many students confuse this because both involve force. A wedge converts force direction, downward outward / splitting. A lever converts force by changing the point of application around a fulcrum. Mistake 3. Forgetting that class 3 levers do not multiply force. Class 3 levers, broom, tweezers, fishing rod, have MA less than 1, they reduce force but multiply distance and speed. The advantage of class 3 levers is speed and range of motion, not force multiplication. Summary. Work equals force times distance, joules. Machine, makes work easier, reduces effort, changes direction, or increases speed. MA equals load / effort. Efficiency, percent equals, more / VR, times 100. 6 simple machines, lever, 3 classes, 1 equals crowbar / scissors, 2 equals wheelbarrow, 3 equals broom / tweezers, wheel and axle, steering wheel, doorknob, windlass, pulley, a fixed direction change, movable MA equals 2, compound heavy loads, inclined plane, ramp, hillside road, long slope, less effort, wedge, knife, axe, cutlass, nail, split / separates, screw or screw jack, nut / bolt, inclined plane in spiral. All complex machines are combinations of these 6. Machines never create energy. Friction means total energy input-output. For homework, A. Identify the simple machine type in scissors, car jack, borehole pump handle, wheelchair ramp, cutlass. B. Calculate MA when load equals 600 N, effort equals 150 N. C. Draw and label the 3 classes of levers. Attempt a quiz on your LMS. Keep exploring the world around you. Visit Litech Academy at academy.litech.com.ng. Until next time.